Hello everyone, welcome to OHM Institute. I am Shankar. In this video, I would like to discuss the previous year questions analysis from KPTCL exam. The subject is power electronics. Now let us look into the first question. In which of the following waveforms RMS voltage is equal to average voltage? Now if you look into the waveforms here, triangular wave, square wave and a sine wave. In all of these three waveforms, I can say square and a sine wave, as both positive half and negative halves are equal in areas, average value could be 0. Of course, for the triangular wave, average and RMS values obviously they are not equal, and hence I can say option D. None of the waveforms, both RMS and average voltages are equal. Now let us move to the next question. What is the definition of crest factor? What is the definition of crest factor? It is basically average value divided by RMS value. Average value divided by RMS value. So these are basic definitions. Okay, next one. This is very popular and important question from power electronics. The SCR can be turned on by, see, if you recollect, turn on methods we can call triggering methods. Okay, we can call them as triggering methods. One method is applying the anode voltage at a sufficient fast rate. So first very basic method, this is not a basic method. First condition is anode SCR should be forward biased. What do you mean by that? Anode voltage should be more positive than cathode voltage. Under that condition, if we supply suitable gate current, then SCR will get turned on. That is one thing. Another way is when SCR is forward biased, between anode and cathode there will be a reverse biased junction J2. So once a forward voltage exceeds forward breakover voltage, then SCR will enter into conduction state. That is one way of triggering the SCR. These are two methods. Another method is by applying anode voltage sufficiently faster rate. In other words, you can say this method is also called dV by dt method of triggering. That is another method. And fourth method is by increasing the leakage currents of SCR, also we can turn on the device. Therefore, what all the methods given here, these are all correct, and hence we can say all the above is the correct answer for this question. Next. The LC series circuit is connected to a DC supply of 100 volt through a thyristor. The peak current through the thyristor will be now if you just look into a circuit diagram for this particular description, I can say LC circuit is connected to a DC voltage source through a thyristor. Okay, and let us say a source voltage is VDC. So when SCR is turned on, how can you express the equation for current? Let us say this is a current I. So here L into di by dt plus 1 by C integral I dt is equal to source voltage. So I am not going with the derivation here. By solving this equation, by applying Laplace transform on both sides, we will get current equation is I is equal to VDC divided by omega L into sine omega t. Therefore, the peak current that is flowing through the thyristor will be VDC divided by omega L. So if you substitute expression for omega, that is 1 by root LC multiplied with L. So it will be simplified as VDC multiplied with root of C by L. So no answer is matching with this. So for this question I can say no answer. But what is the correct answer here? VDC into under root C by L. Next, let us look into the next question. An IGBT is a combination of, see, there are three devices that are considered under transistor family. What are the three devices? BJT, MOSFET and IGBT. So these three devices together considered as transistor family devices. Out of these three devices, BJT will have better properties from the conduction point of view. But as BJT is a minority carrier device, it will have more switching times. Whereas MOSFET, it will have better switching properties, but on resistance is very high, therefore conduction loss will be very high. So from the switching point of view, MOSFET is a better characteristics. From the conduction point of view, BJT has a better characteristics. So the common advantages of these two devices are combined in a hybrid device named as a IGBT. Therefore, we can say IGBT will have combination properties of MOSFET and BJT. Option C will be the correct answer for this question. Next one. Which of the following devices possesses bidirectional current capability? Okay. So if you see the BJT, it will allow the current in only one direction. So it will have unidirectional property, unidirectional switch you can say. MOSFET will also have unidirectional switch, but if MOSFET is considered along with the body diode, then only we can treat it as a bidirectional switch. SCR will also allow the current to flow from anode to cathode. Hence BJT, MOSFET and SCR, these are all comes under unidirectional switches. Triac will have bidirectional property. Hence option B will be the correct answer. Next one. In three-phase controlled bridge rectifier with an increase of the overlap angle, the output DC voltage is, if you see this question asked in so many exams, so can say it is important, may or may not come in the future exams, but important concept. In case of rectifier circuits, input will be generally, whether it is a single phase circuit or three phase circuit, same explanation. Input will be taken from some transformer. So in our analysis, generally we will consider source side inductance is neglected. Therefore output voltage will have certain value. Whenever source inductance LS is introduced, then overlap angle will also come into picture. What do you mean by that? Overlap angle increases is nothing but when obviously overlap will increase whenever source inductance is increases. When source inductance increases, what will happen? The net average output voltage will decrease. When source inductance increases or overlap angle increases, the net average output voltage will decreases. Option D is the correct answer. Okay. Next one. A single phase half-wave rectifier circuit has a freewheeling diode which will conduct only if, remember, freewheeling action will come into picture when the load is inductive. Inductive means what? It can be either pure inductive or RL load. When the load is resistive, there is no concept of freewheeling action. Therefore, Option B is the correct answer for this question. Okay. Next, which of the following bridge rectifiers has highest harmonic content in the output voltage? Now, for this particular question, observe carefully here. If number of pulses in V0 increases, if number of pulses in V0 increases. So, in this case, what is the basic concept? Ripple component in V0 decreases. So, what is the meaning of this statement? Higher the number of pulses, lesser will be ripple component. Ripple component is nothing but harmonic content. So, in all of these circuits, single phase half wave rectifier circuit will have least number of pulses. Therefore, this particular circuit will have highest harmonic content. Higher the number of pulses, ripple component decreases. That means less harmonic component. Lesser the number of pulses, higher is the harmonic content. So, that is the answer. Now, let us move to the next question. A 240 volt 50 hertz supply feeds a highly inductive load feeds a highly inductive load of 50 ohm resistance through a thyristor full controlled bridge when the firing angle is alpha is equal to 45 degree. Output voltage is. Now, what is observed here? Highly inductive load with a 50 ohm resistance. And what is the circuit given here? Single phase full converter bridge. Single phase full converter bridge. What is the load given? RL load. What is the alpha given? 45 degree. What is the source voltage? Vm is equal to 240 into root 2 volt. Okay. Therefore, what is the average output voltage? 2 Vm by pi cos alpha. Okay. 2 into 240 into root 2 divided by pi cos 45. Cos 45 is 1 by root 2. Therefore, if you do this simplification, 2 into 240 divided by pi. 2 into 240 divided by pi. This value is approximately 152 volt. Okay. So, option C is the correct answer. Now, for the same question, of course, with this the given question is over, but the same question if I want to twist, suppose if load is simply resistor, if load is simply resistor, then you should not use this formula. In that case, what is average output voltage? Vm by pi into 1 plus cos alpha. What is Vm? 240 into root 2 by pi. 1 plus cos 45 degree. 1 plus cos 45 degree. This value will come around 184.4 volt. 184.4 volt. If the load is resistive, this is the procedure. If the load is inductive, that is the procedure. Okay, of course, for this question, 152 volt is the answer. Now, Let us move to the next question. It is very interesting and important question also. A single phase 2 pulse bridge converter gives an average output voltage of 400 volt and output power of 10 kilowatt. The SCRs are connected to form a single phase 2 pulse midpoint converter. Now observe carefully what is given here. First arrangement is bridge converter. Now from bridge converter it is moved to midpoint converter. From bridge converter it is moved to midpoint converter. SCRs are same. So in case of bridge converter, what is the peak inverse voltage of the devices? That is Vm. Whereas in case of midpoint converter, peak inverse voltage of the devices is 2Vm. So as the same thyristors are used to form midpoint configuration, what should be the source voltage in the new configuration? It should be reduced by half, isn't it? Because here Vm, for example, I am using a device, let me take one number of a voltage rating of, let us say, 100 volt. Same device I need to use in the midpoint converter. Therefore that 100 volt, in order to sustain, what should I do? I need to reduce the source voltage rating. Therefore but in these two cases expression for V0 and P0 are same. Expression for V0 and P0 are same. So while moving to midpoint converter, as I reduce the source voltage by half, then what these two numbers will become? They will also reduced by half. Therefore 400 volt become 200 volt. Output power 10 kilowatt becomes 5 kilowatt. This could be answer for the question. Next, the chopper circuit is operating on time ratio control principle at a frequency of 2 kilohertz. Switching frequency is given as 2 kilohertz. Let me write 2000 hertz. Okay. With a DC supply of 220 volt. If the load voltage, let me write down V0 is equal to 170 volt. Now what is the question here? Conduction period. So what we need to find out? Turn on time of the switch. It is mentioned as a simple chopper circuit. It is not given as whether it is a step down or step up. Generally in such cases it is good to take a step down chopper. Therefore for step down chopper, what is an expression? V0 is equal to D into VDC. V0 is equal to D into VDC. Therefore first let me calculate D. What is D here? V0 170 divided by 220. 170 divided by 220. This numerical value is 0.77. But what is duty cycle ratio definition? Turn on time by total time. So from this you need to find out turn on time. So T on is equal to 0.77 into T. What is T? Frequency is given as 2000, therefore T will be 1 by 2000. 0.77 divided by 2000. This value is 0.386 millisecond. 0.386 millisecond. That will be the answer. Next, let us look into the next question. The effect of source inductance. This point is already explained. The effect of source inductance on the output voltage of a 3-phase AC to DC converter is whenever source inductance is taken into account, the impact of source inductance is it will decrease the average output voltage of the overall converter, whether it is a single phase and three phase. The same conclusion is applicable in single phase AC to DC converter also. Same concept is applicable in single phase AC to DC converter also. Next, which chopper circuit uses saturable reactor? Generally, this saturable reactor will be used in the current commutated chopper. That is, another word is also called Morgan chopper. Remember, Morgan chopper is a current commutated chopper who is named after the inventor, and Jones chopper is a voltage commutated chopper. Okay. Next, which of the following devices convert fixed DC to variable DC? It is appropriate word not to use the devices. It is appropriate to use circuit. Okay, but in the exam it is given like that. So which of the following circuit convert fixed DC to variable DC? That is obviously chopper. This is also question is based on simple definition. Next one. What type of load should be used in a single phase bridge inverter so that it can operate in the load commutation mode? See, for load commutation to be possible, what is the condition? 1 by LC should be greater than R square divided by 4L square. This concept is nothing but RLC under damped load. RLC under damped load. Okay, now let us move to the next question. See, this question is very important. A voltage source inverter is normally employed when? So before answering this question, I would just draw simple diagram of VSI and CSI. This is voltage source inverter. As the name suggests, for this VSI, input is voltage stiff nature. What could be the preferable load current sink? That is heavy inductive load. Whereas in case of current source inverter, what is source here? Current source is basically nothing but a large inductance is in series with voltage source. In such case, what is the preferable load? So that is a heavy capacitive load. Therefore, in case of VSI, there is no inductance at the source side. So what do you mean by that? Source inductance is small and load inductance is large. Okay, that option is correct. Suppose if the same question asked in terms of current source inverter, then what should be the option? Source inductance is large and load inductance is small. So let me write down here, option A should be used for current source inverter. Option B is for voltage source inverter. So these are the previous questions from power electronics. Apart from these questions, in order to have good practice, I will also suggest you can enroll Home Institute, and if you practice various questions, here we will cover all the topics very zero level to very advanced level. We will provide a lot of handouts for problem solving, and the previous year questions, we will have plenty of questions, and here we faculty are very much approaching towards students. So I will recommend everyone to whoever is interested to appear this KPTCL exam, you can enroll into Home Institute, this program. We are offering both online and offline mode. So with this I will conclude this lecture. Thank you for watching.